Okay, in this video I will go through the exercise 1A from FS1. Okay, FS1 Edexcel. Okay, question 1 says for each of the following probability distribution, write out the distribution of x squared and calculate both E of x and E of x squared. So I already have drawn the table here just to save our time. Okay, so it says the random variable x equals to 2. The probability of random variable x equals to 2 is 0.3. The probability of random variable 4 equal to random variable x equals to 4 is 0.3 and so on. So imagine we've got an unfair dice, for example, or any shape which is four-sided. Okay, in one side it's written 2, another side 4, 6, and 8, and so on. So since it is unfair, when you throw it, the probability of getting 2 is 0.3. The probability of getting 4 is 0.3. Probability of getting 6 is 0.2, and so on. So now we've been asked to find out E of x and E of x squared. To calculate E of x squared, obviously, we need to have x squared answer. What we mean by x squared? Whatever we get, okay, we need to square that, whatever the outcome is. So x squared, if we get 2, it would be 2 squared, which is 4. Then 16. Then 36. And 64. Probability of x squared equals to 2 equals to 4 is the same probability, 0.3. Okay, getting 16 is 0.3, getting 36 is 0.2, and similarly 0.24, 64. Okay, so now let's calculate E of x. In this case, probability of random variable x equals to x is the same as probability of random variable x squared equals to x squared. It is not always the case, but it is, we can say it is true for part A of question 1. For part B, however, it's not true, and I will explain the reason why probability of x equal to x is not the same as probability of x squared equals to x squared. Okay, let's write down the formula for E of x first. E of x is equal to sum of x times probability of random variable x equals to x. Okay, which is equal to x is, for the first case, it is 2 times by 0.3, add 4 times by 0.3, add 6 times by 0.2, add 8 times by 0.2, which is equal to 4.6. So the expected value is 0.6. Now, probability E of x squared is equal to sum of x squared times by probability of random variable x squared equals x squared, which is 4 times by 0.3, add 16 times by 0.3, add 36 times by 0.2, add 64 times by 0.2. Using your calculator, you should be able to get 26. Okay. Now let's move on to part B of the question. So the table is given, The random variables are -2, -1, 1, and 2. And the probability are 0.1, 0.4, 0.1, 0.4 respectively. Okay. Now let's calculate x squared. So -2 squared is 4. In the same way, 2 squared is equals to 4 as well. So therefore, in this case, probability of x squared equals to x squared will not be the same as probability of x equals to x, because we're getting 4. Okay. If, for example, the dice land on -2 and 2, okay, in both cases, x squared is equals to 4. So therefore, probability of x squared equal to 4 will be 0.1 plus another 0.1, which is 0.2. Okay, so -1 squared is 1 and 1 squared is 1. In very similar way, okay, in the same way, 0.4 for 1 and 0.1 for 1 again. So the probability of x squared equals to 1 would be 0.4 plus 0.1, which is 0.5. Okay, so let's calculate probability of random e of x first. Okay, e of x is equal to sum of x times probability of x equals to x, which is -2 times by 0.1, add -1 times by 0.4, add 1 times by 0.1, add 2 times by 0.4. Okay. Which is 0.3. Okay. So, however, for probability of x squared equals to x squared, I can draw another table. Okay. So, x squared and probability of x squared equals to x squared. So, what are the possible outcomes for x squared? It is either 1 or 4. So, in the case when it is 1, the probability is 0.4 and 0.1, which is 0.5. And for 4, similarly, it is 0. This one should be 0.4, which I wrote down 0.1 here. So 0.4, 0.1, which is 0.5. I have to correct the 2 times by 0.1. No, that's correct. Okay. So therefore, the probability distribution for x squared is written as well. Okay. So probability of or e of x squared is equal to, let's move the paper a bit up, e of x squared is equal to sum of x squared times by probability of x squared equals to x squared, which is 1 times 0.5 add 4 times by 0.5, which is 2.5. Okay, end of the question 1. And now let's move on to another question. Let's say question 4. Okay, so Question 4. A random variable x has probability function given by probability of random variable x equals to x is equal to 2 to the power of minus x when x is 1, 2, 3, and 4, and 2 to the power of minus 4 when x is equals to 5. Construct a table giving the probability distribution. Okay, let's write down the probability function first. Probability of x equals to x is given by 2 to the minus x, 2 to the minus 4, 2 to the minus x when x is equals to 1, 2, 3, 4. Okay, x equals to 5. The probability would be 2 to the minus 4. Okay, so the probability of, for example, outcome of 1 is 2 to the power of minus 1, or 1 over 2, which is half, and so on. Okay, let's draw a table for probability distribution table for this question. Okay, so first of all, the possible outcomes are 1 to 5. Let's draw the table. Okay, x and probability of random variable x equals to x, 1, 2, 3, 4, and 5. Okay, so when x is equals to 1, 2 to the power of minus 1, or half. When x is equals to 2, 2 to the power of minus 2, which is 1 over 4. Similarly, 1 over 8, 1 over 16, and we know for 5 it is 2 to the power of minus 4, which is 1 over 16. Okay, so B, it says calculate EX and EX squared. Okay, so I leave some space. I might need to extend the table. E of x is equals to sum of x times probability of x equals to x, which is 1 times half plus 2 times water plus 3 times 1/8 plus 4 times 1 over 16 plus 5 times 1 over 16. Using your calculator, you should be able to get 31 over 16. You can write it as a decimal, like 1.9375. Okay. Now we need to work out E of x squared. Of course, this is part B, and this is A. E of x squared is sum of x squared times by probability of random variable x squared equals to x squared. Okay, first of all, let's work out all the x squares. Okay, let's extend the table. X squared. 1 squared is 1, 2 squared is 4, 9, 16, 25. Probability of x squared equals to x squared, which is half, quarter, 1/8, 1 over 16, and 1 over 16. Okay. So it would be 1 times by 1 over 2 plus 4 times by 1 over 4 plus 9 times by 1 over 8 plus 16 times by 1 over 16 plus 25 times by 1 over 16. Using your calculator, you should be able to get 83 over 16 or 5 and 3 over 16. Okay, part C. State whether or not E of x all squared, E of x all squared is equal to E of x squared. Okay. State whether or not. Okay. So first of all, what did we get for E of x squared? E of x squared is equal to 83 over 16. And E of x all squared is the same as E of x, which is 31 over 16 all squared. Okay. So we get 3.7539 for decimal places. While E of x squared is not the same. So let's write down E of x squared as a decimal if we can. So 83 over 16, which is equal to 5.1875. So therefore E of x squared is not equal to E of x whole squared. Okay, so end of the video, and in next video we will go through 2 more questions of this exercise.